Today we're going to be talking about system of equations with 3 equations and 3 variables. So remember, the solution of a system of equations is the intersection of the graphs. But this time with a system with 3 variables, x, y, and z form an ordered triple, which is x, y, z right here. So 3 variable coordinate systems is 3-dimensional. So notice here we have an x, a y, and a z, and this graph looks totally different. So we're looking at this, actually you can think about the view of this graph would almost be looking from like a perspective up here. So you're looking down, and then this is x, y, and x, y still would look like a graph like this, but picture that you're literally, you see how you're looking at this on the paper, and the z is coming out of the paper at you. I don't know if that makes sense. It's kind of hard to explain over video, but that's how, but then we just draw it like it's drawn here. So z is like sticking out of the paper and you're looking down at x and y. Okay, so this example would tell you to go 3 forward, because this is x. Okay, so 3 forward, 2 left, so 2 left, and then 4 up. So like right there. So you'd go 3 forward, 2 left, and 4 up. 3 forward, 2 left, 4 up. Okay. Here's a note. The systems with 3 variables can be solved by graphing, but it's not practical. To solve systems of equations with 3 variables, we will use elimination. It is possible to use substitution, but here we're going to just be using elimination. The solution types are one solution, no solution, or infinite solutions. Okay, so we have 3 problems. These are the only 3 problems we're going to do for these notes. So let's take a look at number 1. It says x plus 4y plus z equals 3, 2x plus y plus z equals 11, and 4x plus y plus 2z equals 23. So we have x, y, and z in this equation. And we have 3 equations instead of 2. The good thing is, when we solve with elimination, we're doing exactly the same thing. We just have to get rid of one of the variables. And we're going to use 2 equations. Okay, we're still using 2 equations. I'm going to label them up here, 1, 2, and 3. And you're going to choose a variable to eliminate twice. So you're going to say, so this time we just chose z. Okay, the reason is because you can just take a look. It doesn't matter. Like we could have done the y. You see how both of these y's just have a 1 in front of it? The x's, we'd have to multiply a little more. The y's or the z. You could choose anything. It doesn't matter. We're just going to choose z for this example. Okay? So we're going to multiply -1 to our first equation. We're going to choose our first equation and we're going to multiply -1. That way, we're going to get a -z. So you see how we just changed all the signs. -x, -4y, -z equals -3. Then I'm going to choose the second equation, and the second equation I'm not going to change at all. That way the z's cancel out. So we chose the z to eliminate, so we have to make them the same number in front, which is a 1, and just opposite signs. The z's cancel, and we're going to add down just like we do when we're doing elimination with 2 variables when we have 2 equations. So -x plus 2x is x, -4y plus y is -3y. These cancel, and -3 plus 11 is 8. So I'm putting a star. We're going to call this equation star. Now we're going to eliminate the same variable, which is z, because we chose z at the beginning, with 2 other equations. Okay, so we chose 1 and 2 before, and now we're going to choose 2 and 3. So 2, I multiplied by -2, so then that way we can get these to cancel. See how it has the same number but opposite sign. So I multiplied everything in equation 2 by -2. So this is now a -4, this is a -2y, and this is a -2z, and this is a -22. So everything by -2. That way these can cancel, and we're going to add down again. Now look what happens to our x's. Our x's actually cancel too. So the x's cancel, the z's cancel. We're left with -y when we combine to the y's equals +1. Remember, we have to divide by -1, so y is -1. So now we actually have our y. We have our y. Now we just need to find x. and z, and then we'll have all three of them. So x minus 3y equals 8. I'm going to take this equation here. See how we have our y, our answer for y, and we're going to plug it in here for y, and I'm going to solve for x. So I'm going to plug -1 in for y and solve for x. X plus 3 equals 8, and then x equals 5 when we solve that. So now I have my x and my y. Now I have to find z. So I just decided to choose this first equation. You can choose any of them. By the way, the reason we plugged the -1 for y back into this equation and not any up here is because we only had -1 on the step. We didn't have our x, we only had our y. So if we plug y back into any of these three equations, we're still going to have an x and a z left, and we only should have one variable, right? Because if we plugged in -1 here, and then we had an x and a z, that's not going to help us. So we plugged in -1 here to this new equation that we got. So then that way we can get rid of the y, because now it's -1, and then we're just going to solve for x. So that's why we chose that equation. Now we can choose any of these three, and we're going to plug in x and y and just solve for z. So z is 2 when you solve all of that. All right, number 2. So we're going to label them again, 1, 2, and 3. And this time we're going to eliminate y. Look at equations 1 and 3. So you're just going to study this ahead of time, and you're going to say, okay, 3x, x, and 2x, I can't cancel anything. And I'd have to multiply here, z, -3z, and z. I could multiply one of these two, like equation 1 and 3, by a -1 and get rid of them. But look at the y's. The y's are already ready for me. This is a positive y, this is a negative y, so those will cancel without me needing to multiply anything. So I'm going to choose the first and the third to use. And I'm going to cancel the y's out. I'm left with 5x plus 2z equals 7. So now I put a little star there because that's one of my equations. And now I'm going to choose equations 1 and 2. Remember, we have to eliminate y a second time. Okay, we have to, so if we choose y at the beginning, we have to choose 2 other equations and eliminate y again. We see how we chose 1 and 3 and then 1 and 2? We could have chose 3 and 2 instead of 1 and 2. So you could mix these up. You don't have to, I'm just showing you an example. Obviously, I'm not showing you every single way we could do it. But we decided to choose 1 and 2. So we multiply -2 to the first equation. Okay, and then when you multiply -2 to the first equation here, that's going to be a -2y, so that's going to cancel. And we're left with -5x minus 5z equals 5. You're going to take both of these equations now. Notice, now you have an x and a z, and you're going to take both of these and stack them on top of each other. Last time, in our last one, we got lucky, and the x's canceled, the z's canceled, and we were only left with y, so we were done. And we could plug that y back into here, right? But in this one, only one of our variables canceled. So now we're going to take both of these equations, we're going to stack it on top. Now we have a new system. Now this, our new system here, we're going to solve this new system. We're going to find our z, because look what's going to happen to the x's. The x's are going to cancel out. And now we're just doing a system of 2 equations with 2 variables. So this is just like elimination on the last video notes that you had for last class. So now the 5's cancel. 5x minus 5x is 0. So we have -3z equals 12. Divide by -3, and you have z equals -4. Okay. Now you're going to find x. So we just chose the first equation here. You could have chose the second one. Either one of these we could plug back in, -4 for z, and we're going to find our x by solving. So x here divided by 5 at the end, and it's 3. So now we have our x, our z, and we're going to find y. So I just chose the first equation. I'm going to plug 3 in for x, and I'm going to plug -4 in for z, and I'm going to find y. Okay, so 3 times 3 here is 9. Bring down the y, bring down the -4. Combine like terms. 9 minus 4 is 5. So you have y plus 5 equals 5. Subtract 5 on both sides, and y equals 0. So now you have all 3 of them. All right, number 3, we're going to label them 1, 2, and 3 again. Look at equation 2 this time. Equation 2 only has 2 variables, right? So pay attention to that. It doesn't have an x. So this time we're not going to choose equations 1 and 2 or 2 and 3. If we choose equation 2 with anything, we're actually going to get an extra variable back in, which is just going to make it a little longer. So I would choose, you see how these have 3 and these have 3? I would choose 1 and 3 first to eliminate x. Okay. We could have also eliminated z. We could have eliminated anything, but this time we're going to eliminate x. So I'm going to multiply the top equation by -2. Now the x's cancel, and we're left with -3y minus 4z equals 1. Okay, notice here, see how we used 1 and 3 and we didn't use 2? Do you see how y and z, do you see how both of these have a y and a z? So I can use my equation 2 now and actually put it right below it, and I can stack those two, and that's my new system. And I'm going to solve this time for z, because look, the y's cancel out. So I don't have to multiply anything. Those are just going to cancel. And I have -5z equals 5 divided by -5, and I have z equals -1. Then I'm going to plug -1 back into either one of these equations. So I'm just going to choose equation 2. I named this equation star, by the way, so I just brought that down. And then I brought the equation 2 down. All right, so we're going to plug in -1 for z. We're going to find y. Then we have z, y, and we're going to plug it back into any one of these. Well, actually, we can't plug it back into 2 to find x, right? Because 2 doesn't even have an x. So either 1 or 3. We're going to choose to plug back in, and then we're going to plug in 1 for y and -1 for z and solve for x. So x is -3. And this is how you'd write it, by the way. You would write it x, comma y, comma z, x, comma y, comma z. This should also be written as 3, 0, -4.